Dear students, a second issue that we consider in the context of instrumental variable method of estimation is how to detect weak instruments. In an earlier session, we have discussed the problems created by weak instruments. Now consider the model y is equal to beta 0 plus beta 1 x plus u, and x and u are correlated in the simple linear regression model. And we have shown that if the instruments are weak, then you will get biased estimates. You will get biased estimates, and also that even in large samples, the bias will not disappear. That is, even in large samples, the distribution will not converge to the population parameter. This is true not only in the simple linear regression model, this is also true in the case of multiple equation model that we have considered y1 is equal to beta 0 plus beta 1 y2 plus beta 2 z1 plus etc. beta k z k minus 1 plus u1. So, whether we have a simple linear regression model or whether we have a multiple linear regression model with z1, z2, etc., zk minus 1 as exogenous variables, y2 as endogenous, the problem of bias persists. The problem of bias persists if the instruments are weak. Now, in order to determine the bias or the problems caused by weak instruments, a study was conducted in 1997 by two econometricians, Steiger and Stock. By Steiger and Stock. Their study is based on the condition that all instruments are exogenous. First, they ensure that the instruments are exogenous. That is a point which we will see in the subsequent class. In the last class, we have discussed the case in which explanatory variables are endogenous or exogenous. We also have to determine whether the explanatory variable, the instruments are exogenous or not. That is covariance z u equal to 0 or not. In the simple linear regression model, z is suggested as an instrument for x, and the two conditions for z to serve as an instrument, covariance x z not equal to 0, covariance z u is equal to 0. So, the Steiger-Stock study is based on the assumption that instruments are exogenous. And with the exogeneity requirement satisfied, they focus on cases where instruments are weakly correlated with the instrument z is weakly correlated with x here, or instruments in this model. Suppose that we have z k and z k plus 1, two instruments. for y2. So, the cases where instruments are weakly correlated with the y2, whether there is only one instrument, whether there are more than one instrument. Instruments are weakly correlated, and they studied in detail the validity of standard errors of estimators, confidence intervals, t-statistics involving the coefficients beta 1 of y2. And their finding is that even with a large sample size, two-stage least squares estimator can be biased and its distribution can be considerably different from normal, provided that Z is weakly correlated with the y2. That is, the problems associated with the weaker instruments. And building on the study by Steiger and Stock and in the year 2005, Stock and Yogo. In the year 2005, Stock and Yogo proposed methods of detecting situations where weak instruments lead to substantial bias and distorted statistical inference. So, Stock and Yogo in 2005 suggested situations in which studies based on instrumental variables lead to statistical bias and also distorted inference procedures. And they developed rules concerning the size of t statistics and ft if there is single instrumental variable, f if there are multiple instrumental variable. They developed rules concerning the size of t if there is only one instrument, f if there are many instruments, from the first stage regression. In the first stage regression, we regress, in the general case, we regress this y2 on all the exogenous variables included and excluded, say z1, zk minus 1, zk plus 1, etc. We regress y2 and obtain y hat 2. So, in the first stage, if there is only one instrument, we regress y2 on z1, zk minus 1 and zk, and the t of zk is considered. If there are many instruments, we cannot take a t. So, we test the joint hypothesis of zk and zk plus 1 using the f test statistics. So, the key implication from the Stock and Yogo study is that one needs more than just a statistical rejection of H0 in the first stage at usual significance levels. Now, Stock and Yogo suggested that we can proceed with the instrumental variable method if the t from the first stage is greater than root 10 is equal to 3.2. An absolute value of root 10. And remember this, for statistical significance of the coefficient of ZK, T of 1.96 is enough. So 3.2 is, this is the 95th percentile from the T distribution. So 3.2 means we require greater than 95th percentile from the standard normal distribution. In the case of a single instrument, in the first stage, T must be 3.2 in absolute value, negative or positive. Similarly, when we have a multiple regression model, so in a multiple regression model with a single endogenous explanatory variable, T must be 3.2 or high. In the case of multiple instruments, that is the cases in which we use two-stage least squares, in the first stage, F must be greater than 10. This is T, and we know that T square is equal to. The requirement is, if we have multiple instruments, we cannot test the significance using t-test. So we test the overall significance, not overall. We test the significance of ZK and ZK plus 1 using F, and F will be greater than 10. And we know that T square is equal to F. So in this model, the first stage is, say, y star 2 is equal to pi 0 plus pi 1 Z1 plus pi 2 Z2 plus pi 3 Z3. Suppose that the instruments are Z2 and Z3. Z1 is in the original equation itself. Then our null hypothesis pi 2 is equal to 0, pi 3 is equal to 0. To reject this, join this hypothesis, F should be greater than 10. And remember this, we are not considering the overall significance here. For calculating F, we consider only Z2 and Z3. Z2 and Z3. We will not consider Z1. So we are not testing the overall significance. So the point is, if there is only a single instrument, T must be greater than 3.2 in absolute value. If there are multiple instruments, then F must be greater than 10 in the first stage, when we regress the endogenous explanatory variable on all the exogenous variables. Then only we can say that the instruments are strong, so that we can proceed with the 2SLS. Otherwise, the instruments are weak, and if the instruments are weak, you will get biased estimates, and the bias will not disappear even when the sample size increases indefinitely. That is a second issue to be kept in mind when using instrumental variable method of estimation. The first one is whether an explanatory variable is correlated with U or not. The test is Hofmann test. The second is whether instruments are strong or weak. That is the second step.